Hashtag Sunday Thought has a thought experiment by physics lover. What is the weight of Earth? We have two ways to find the weight of Earth. First is geometry and the second is gravity. In the first, geometry, we assume that the Earth has a sphere. In volume of Earth is 4 by 3 pi r cube. Mass of the Earth is density of the Earth into volume of Earth, where the density of Earth and the volume of Earth put is 4 by 3 pi r cube. We don't know the density of Earth and the radius of Earth, so we move to the gravity. In the gravity, F is g m of m by r square, where the m of E is mass of Earth, m of m is mass of man, and r of E is the radius of Earth. In the free falling, F is mass of man and the gravitational acceleration g. So we put them and we find them. Mass of Earth is gravitational acceleration, radius of Earth square by gravitational constant. In this, we don't know the gravitational acceleration, gravitational constant, and the radius of Earth. In two cases, we don't know the radius of Earth in both. So first we find that a Greek astronomer Eratosthenes find the Earth's radius is 3700 km in 2000 BC. Their experiment is shown in that in the sunlight fall two cities, where two cities has the distance of x. In those shadow of two cities has the angle of theta and phi. We measure this angle to the theta minus 5. In this we know the x, we know the angle. So in the trigonometry we find the radius of Earth in this place. In the picture of Earth, scientists came out the conclusion of that the Earth is not sphere, it's oblique. It is 42 kilometers shorter in pole sides. So the radius of Earth is 6378 kilometers in the variations of pole and the near about the surface. In Henry Cavendish came with the experiment to find the gravitational constant. The experiment is this: in the middle center, a rod has mass of m in two sides, and it has a torque of tau. So they move in the direction of this. In that, mass of m is the bigger than the mass of m, so we put m to the find of gravitational constant, where F is g m by r square, where the F dot L of the length of the rod, k is the two-region coefficient of rod, theta is the angle rod spins around. That put in the value of F, so we came out the gravitational constant G is k theta square by m, where we have all the values. So we find the gravitational constant G is 6.74 into 10 raised to minus 11 meter cube per kilogram per second square. In the second experiment of gravitational acceleration finding, the Newton's equation of motion says that one object free fall in gravitational acceleration has h is ut plus half of at square, where the free falling object has initial velocity is 0. So we came out the small g, or the gravitational acceleration is 2h by t square, where we know the height, we know the time. So we came out the g is 9.8 meter per second square. In the second case of gravity, we put the small g, radius of Earth, and capital G. So we came out the mass of Earth where mass of the earth is 9.8 into 6378 into 1000 whole square by 6.67 into 10 raised to minus 11. So the mass of the earth is 5.95 into 10 raised to 24 kgs, which is the 6 trillion kilogram. In the first case, the density of the earth dE is measured by, so the dE is me by 4 by 3 pi r cube, where the density of the earth is 5.52 into 10 raised to 3 kg per meter cube. It is said that the more you find, the more appears that you have to find. So in all of this, we go to the find of Earth's weight, and we find that the radius of Earth, the gravitational constant, the gravitational acceleration, and the density of Earth. You are guys amazing. Thank you for watching Physics Lover.